For lesson 1, we're going to begin our work with coordinate geometry, and we're going to start with a new type of equation for our lines. So the first part here is going to review y equals mx plus b, which we already know. So it says determine the slope between the points a, 6, 4, and b, 9, 5. So if you remember, in y equals mx plus b, our slope is m, and here is our formula, y2 minus y1 over x2 minus x1. In other words, change in y over change in x. And if we look at our 2 points, it doesn't matter which one you label x1, y1 and x2, y2. So I'm just going to go a is x1, y1 and b is x2, y2. So as I plug into my formula here, 5 minus 4 over 9 minus 6. So 5 minus 4 is 1, 9 minus 6 is 3, and my slope here would be 1/3. Sketch the graph of the line containing points A and B on the axes below, and label the relation of points as line K. So you only need 2 points to make a line. So let's graph the 2. So 6, 4. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4. So there's A. And then B is 9, 5. So 9, 1, 2, 3, 4, 5. Now, I would use a ruler of some sort, but I'm going to make a line that connects these 2 points. And what I'm going to do is I'm going to basically connect it all the way across the graph. Okay. Now, because we can extend it, we have to remember that that line gets arrows. And then they wanted us to call this line K. So I'm going to put a K by one of my arrows off the edge of the graph. Determine the y-intercept of here. Well, I should underline a different color here. Our y-intercept is where our line hits our y-axis, and that occurs at y equals 2. All right. So now what we want to do is we want to write the equation in slope-intercept form, which in other words is y equals mx plus b. We found our slope in the beginning to be 1/3. We just found our y-intercept to be 2. So therefore, y equals 1/3 x plus 2. All right. So that's the equation of lines that we know. And again, it's very easy when you know the slope or can find the slope and then can find your y-intercept. However, in Algebra 1, we focused on all that, but what happens when your y-intercept maybe isn't available? So the reason that y equals mx plus b is called slope-intercept form is because in order to write the equation, you need the slope and you need the y-intercept. What happens when you don't have the y-intercept? Well, we have a new form. It's called point-slope form of the equation. And here's what it says. Y minus y1 equals m parentheses x minus x1. So m is still going to be your slope. All right, that's not going to change. The first y and the first x always remain unchanged. Okay, that literally is going to stay y and stay x. The y1 and the x1 are going to be some sort of point on your line. Now, obviously, there's an infinite number of points on the line, so you just pick any one that you would like. Okay. So let's also, I want to turn your attention to the fact there are minus signs in here, so we have to be careful when we write our equations, especially if there's negatives and stuff like that. Okay. So let's prove that this equation works. Given the equation of line P is y equals 3x minus 2, select a point that lies on point P. So what I'm going to do to make my life easy is I'm just going to go to y equals. I'm going to do 3x minus 2, go to my table. Now what I want to do is I want to take a negative point here, just because I want to show you how some of the negatives work. So I'm going to choose the point -2, -8. Okay, so -2, -8. Use this point and the slope to write an equation in point-slope form. So just to make sure that we have our equation on our page here, y minus y1 equals m parentheses x minus x1. So we should know from above here that our slope is 3. And then we said we're going to use the point -2, -8. So there's our x1 and our y1. All right. So let's plug into the point slope. So the first y always stays the same. Now it's minus -8. Okay. Now normally how do we see this written? Well, minus minus becomes plus equals. Our slope is 3. parentheses, our first x always stays the same, and then it becomes minus -2, which again becomes plus plus. So if we were to clean this equation up, we'd have y plus 8 equals 3 times x plus 2. There's our equation in point slope form, okay? And this counts as an equation of a line, okay? So you don't have to always make it look like y equals mx plus b unless it asks you to. If it just says to write the equation of the line, now this one said point slope, but if it just says write the equation of the line, you can stop right there. In the last piece though, we want to rewrite the equation using algebra to show the equation in slope-intercept form. So basically what we want to do is, just to show you that it's the same as the y equals 3x minus 2, we want to take this equation and make it say y equals. So we'll start by distributing. Y plus 8 equals 3x plus 6. Well, minus 8, and y equals 3x minus 2. So you can see from the very beginning that we have now found our slope-intercept form based on our point slope just by distributing and rearranging. Determine the equation of a line in slope-intercept. So that's y equals mx plus b. That passes through the point 2, -5 and has a slope of 1/2. So actually I'm going to show you two different ways to do this. Now, ideally, you're going to get comfortable with this slope-intercept formula, okay? And that's what I'd prefer, but if we look here, we've got x1 and y1. So y minus -5, so we're plus plus, equals, slope is 1/2, parentheses x, and then because it's -2, or because our coordinate is positive, it's going to read x minus 2. All right. Now again, if they just said write the equation, you could stop right there. But since they said in slope-intercept form, we now have to distribute and solve. So y plus 5 equals 1/2 x minus 1. We will subtract the 5 on both sides, and we get y equals 1/2 x minus 6. Okay. Now, the other way I'm going to show you is I'm just going to show you how you can work with the y equals mx plus b formula right off the bat. So if you know the point or one of the points on the line and you know the slope, we can plug in to solve for b. So the -5 will go in for y, the 1/2 will go in for m, the 2 goes in for x, and then we are plus b. So -5 equals 1/2 times 2 is 1, plus b, minus 1 minus 1. -5 minus 1 is -6. So there's our b, there's our y-intercept, and then we would have y equals 1/2 x minus 6. Now this works out really well, especially because we have a really nice y-intercept. It's an integer. We don't have to worry about some crazy fractions or decimals that sometimes get created through this process. But there are two different ways for you to do the same problem, okay? What I'd like you to do is pause the video now and try example 2 on your own using either one of those methods, kind of up to you. So I'm going to choose to do this through our point slope form because that is what I would like you to get used to, and that is what needs the most practice, obviously. So x1, y1, so a slope of -2. So y minus 13 equals -2, parentheses x, minus -3, so minus minus becomes a plus 3, just to kind of clean everything up in the very beginning. So again, it says slope-intercept form, so we have to distribute. Y minus 13 equals -2x minus 6. We'll add the 13 to both sides, and you get y equals -2x, and -6 plus 13 gives you a positive 7. So y equals -2x plus 7. If you chose to do it by solving for the y-intercept first, you should have had b equals 7, and then you would have gotten the same answer. So again, these work really well because our y-intercepts have been rather simple to work with. But if we look here, this is where using y equals mx plus b becomes a little bit of a problem. It says determine the equation of the line graphed on the axes below in point intercept. Okay, and actually that should say slope intercept. So you can see our y-intercept there is not an integer. So it's not an integer, which makes it a little bit hard to pick off the graph, and we don't just want to guess. I mean, it could be 2/3, it could be 3/4, it could be 4/5, like it could be some crazy number that we don't know. So what we want to do is, we know we need our slope. So y2 minus y1 over x2 minus x1. Now, pick any 2 points that fall perfectly on the graph. So I'm going to pick that one, and then I'm going to pick that one right there. Okay, so my points there are -3, 0, and 1, 1. Okay, so x1, y1, x2, y2. So our formula is going to read y2, so 1 minus 0 over 1 minus -3. So 1 minus 0 is 1. 1 minus -3, so minus minus becomes plus plus, we get a 4. And then our slope there is 1/4. Okay, yes, you could have also counted it off the graph by going up 1 over 4, and you would have accomplished the same thing. So now that we have our slope, we know we can't find our y-intercept right away. So you can use that same technique of solving for b, but this is where using the point slope form comes in handy. All right, I'm going to write it again just so we get used to it. Y minus y1 equals m parentheses x minus x1. Now you can choose either one of those points. Now I'm going to choose this one because I want to show you what it's like to have a 0 in there. So we have y minus 0 equals, we just found our slope to be 1/4, parentheses x minus -3. Okay, and we know our minus minus really becomes plus. You could have cleaned that up right away. So if it just said write an equation, we could stop right there. But because it says slope intercept, we're going to distribute. Now, y minus 0, do we really have to write minus 0? No. So it just becomes y equals. When we distribute that 1/4, we get 1/4 x, and then 1/4 times 3 is 3/4. So then there's our equation of our line. We have y equals 1/4 x plus 3/4. Okay, so what we want to do here is we just want to leave it there. You can use decimals, especially like, I mean, this one's fairly easy. It's 0.75. But I would say when in doubt, keep it in fraction form, concerning your slope is usually a fraction. So you might as well just keep it there. Write the equation above in point slope form. We're not going to make the table, but we already did that. That's actually how we started. So I'm just going to recopy it of 1/4 x plus 3. Okay, so we did our point slope form to start actually, instead of using, the reverse way to solve for our y-intercept. So therefore we kind of accomplished this piece already. So now what I'd like you to do is pause the video, and I want you to complete exercises 1 through 5. So you can see it tells you to do things both ways, point slope form and slope intercept. So my suggestion would be, you might as well write it in point slope form first, and then translate it into slope intercept form afterwards. But pause the video for a couple minutes so that you can try these on your own, and then check back to check your answers. So the first one, the slope of the line is 3. So there's our m, and the line passes through the point 6, 7. So there's x1, y1. So y minus y1, so y minus 7 equals 3 parentheses x minus 6. All right, so there's our point slope. And then if we wanted to distribute it and actually put it into slope intercept form, it would be y minus 7 equals 3x minus 18 plus 7 plus 7, and y equals 3x minus 11. and there's our slope-intercept piece. Same thing for number 2. The slope of a line is 2/5 and passes through the point -5, 7, x1, y1. So y minus 7 equals 2/5 parentheses x. That'd be minus -5, so we are plus 5. So there's our point slope form. I'll rewrite it again so that I can do the distribute. Y minus 7 equals 2/5 x, and then 2/5 times 5 is plus 2. Will be plus 7, and y equals 2/5 x plus 9. The slope of the line is -3/2, and the line passes through the point 10, -3. So x1, y1. So y minus -3, so we'll clean it up and just write plus 3 equals -3/2, x minus 10. Okay, so rewrite it over here to be able to distribute. Now, if you just want to distribute off your first writing, that's fine. So y plus 3 equals -3/2 x. And then -3/2 times -10 is a positive 15. All right, again, you can just use your calculator for that. So minus 3, and you get y equals -3/2x, and then plus 12. 15 minus 3 is 12. For 4 and 5, we have a little bit extra work to do because it didn't tell us this slope. So what we have to do is we have to take a second here to find our slopes that we're able to work here. So I have -4 minus -7 over 4 minus 5. This gives me a plus, so positive 3 over -1, which is really just a slope of -3. Now we can use either one of those points. So I'm going to go y plus 7 equals -3 parentheses x minus 5. So that'll be my point slope equation. If I rewrite that over here, then I can distribute. Y plus 7 equals -3x plus 15 minus 7, and I get y equals -3x plus 8. All right. And in this last one now, we have the same amount of work to do. We have to first find our slope between those 2 points. So 1 minus 7 over 2 minus -4. 1 minus 7 is -6. That becomes positive, so that gives me a positive 6. Gives me a slope of -1. So I get y. Now I'm going to choose the second point here because it doesn't have any negatives, so I don't have to worry about converting any signs. So y minus 1 equals -1 parentheses x minus 2. Just so you're aware, those are the same thing. So if they don't put the -1 out in front, it's kind of like the difference between -x and -1x. They're really the same thing. So that's just like a quick little notation piece. And then if I rewrite this over here so that I can distribute and solve, I get y minus 1 equals -x plus 2 plus 1. I get y equals -x plus 3. So there's our first lesson on our introduction to a new way of writing equations, which is called point slope form.